right, thank you. Apologies, so we had a little technical hitch, and Alexis is trying to reboot his laptop, and will be hopefully joining us back in a few minutes, so we can start without Alexis, and I'll do my best to take you through all of the content we have for you today. So without further ado, let me start. So the presenters today were meant to be Alexis and myself, so hopefully Alexis will be joining us. My name is Gillet, and I'm the R&D director at Hiphen. So a few words before we kick off. So for this presentation today, we'd like to thank our partners at the AKER project. So the results we are going to present to you today are the fruits of the work we have been conducting for the AKER project over the last few years. So it's been 5 years now we've been working on this project, and this is thanks to the AKER project and thanks to Florimond Desprez, our partner for this R&D project. So thank you very much for allowing us to present to everyone the results and the great work we've done together over the last few years. So today's webinar is basically divided into 5 sections. We'll start to talk about Cercospora itself. So what is Cercospora? We'll talk about the equipment. So what kind of equipment did we use? We'll talk about methods and results, and about Cloverfield, our data platform that allows us to automatically compute everything. And then we'll end up with a Q&A session. So without further ado, a few words first about Hiphen. You might already know us, but just a quick reminder that at Hiphen we are experts in plant diagnosis. And one thing we wanted to mention that is very important in the context of this presentation is that we use a wide range of devices. We do not have one single device like drone that we play with at Hiphen. We have a wide portfolio of devices ranging from satellite drones to phenomobile, so unmanned ground vehicles, and handheld devices and IoT devices as well. So we are specialized in merging and combining the data coming out of all of these devices together. This is really what makes Hiphen special, and you'll see in today's presentation that this is very relevant. So jumping in about Cercospora itself. So Cercospora is a disease that we assess here in sugar beet breeding trials. Cercospora is a scavenger that will basically eat up the leaves, and you can see here on the scale that we represented the way as humans we try to visually score the impact of the disease. So we have a scale from 1 to 9, and this is coming from the experts in the field, and they basically here give us an indication of the impact that the disease had on the plant. And the job that we try to achieve at Hiphen is to convert the experts' visual score into a quantitative and objective indicator. One big important point that we want to highlight is the fact that this is a multi-year program. So we started in 2015, so the first 2 years were about the feasibility campaign on a limited number of microplots where we merged drone and phenomobile data. Then 2017 was for us a validation of the R&D modules that we developed, and since 2018 we are in production mode. So we compute the indicators today in routine, and this is a data pipeline that is working in routine indeed. There's also a paper coming out as part of plant genomics. Here we just showed you a sample of the manuscript, but there is a scientific paper that we would be delighted to communicate about when it's published in the journal. And in this paper, we really try to share all of the knowledge we gathered in this project. So if we focus now on the production part of the full program, so 2018, 2019, we went in the trial with the drones, acquired a lot of data, and here we will be talking about purely this part of the project. How does it work? We basically run 8 flights in the trial. The first flight is to get the first measurements and work on the trial mapping. The second flight is to get a baseline, at which point the breeder starts to inoculate the disease in the trial. And then from the third flight onward, then we have visual scorings from experts in the trial that takes they attribute the scores, human scores, to the trial. So in a nutshell, if we think about the methods, we really thought about two ways to assess Cercospora, and there is really only 2 ways to do it. What we call the direct measurement, and here this is probably the best way and the most effective way to do it, is to really go and assess exactly what we can see with a human eye. So here we are talking about directly assessing the number of spots on the leaf, and this requires very high resolution, and this is something that can be done by us humans, because our eyes are really optimized to get this level of information and really spot the very details that we are interested in here. Or it could be done with a phenomobile, because a phenomobile is the only equipment that can reach, given its resolution, the same level of information and the same level of details. So here we are talking about directly measuring and assessing the spots on the leaves. And the other way to do it is what we call an indirect measurement. And here we are talking about monitoring the biomass with UAV, which obviously has a lower resolution than the phenomobile. So with that, then here is an example of what a direct measurement can do. So with the score given by the expert and the phenomobile, you can see an example here from either RGB data or multispectral data coming from the Hiphen camera. You can actually see everything in a very high level of details, very high resolution. And this means that it's very easy in a way to score the Cercospora infestation when it goes from score 1 to score 5. So the first few notations here, up to score 5, really requires this level of resolution to give an objective score for that. So here we are really talking about the early development of the disease. And when we talk about the indirect measurement, here we really talk about how we can link up the scores so for the assessment of the necrosis to a monitoring of the biomass with UAV data. And the methodology that we look at here is really to make the link between the score and the F cover. So I'll show you in a second how we do that. But here the important thing is to know that this is something that is done when we start to hit score 6. And effectively what it means is that typically breeders would stop the trial in a sense when they hit score 6 or 7, because that's when you only rely on visual scores. At this point, you know exactly which cultivar is more resilient than others for the disease, and that's enough for you. But here, for this method that we are applying, we see that it's very important to actually go all the way to the end of the senescence pattern. So we really need to have at least 8 flights to be able to get the scores up to 9, I guess. So all the way through. And basically, the method that we developed is looking at F cover and and we look at the area under pressure curve for this F cover. So this is the in the paper that we are publishing. You will see all the details about this methodology, but this is the approach that we take, because we found that this is the best way to assess the severity of the Cercospora disease on the sugar beet. And you can see the results here. Basically, when we compute everything, you can easily spot on the trial's orthomosaic the microplots that have been badly affected and those that were more resilient. You can see on the scale on the right hand axis here an example of one microplot that was badly hit by the disease, and one that's been very resilient. And you can see what an average microplot will, how an average microplot would behave here as well. So the data that we capture with the drone really helps us to get to this level of analysis, this level of details. And with the extraction of each microplot, we can easily go and inspect the results. And this is pretty cool for us, because we can see year on year how the disease impacted the plants. So we can see, for instance, that in 2018, the disease behaved, the infestation was very different to 2019. And this is surely due to different weather conditions, but we can really go to this level of analysis year on year, which is very interesting, and can provide another level of insights and value to breeders. And when it comes to validation, in the paper, again, we list all of the validation that we could do since 2015. So here we have 2016, 17, and 18 represented. That basically shows that on phenomobile, you get very good results. And once again, this is due to the high resolution of the phenomobile that allow us to go very close to what we can achieve with the human eye and the expertise from the ground. And with UAV, we managed to derive a methodology that is very robust and that allow us to sort the microplots with a very accurate and very good level of accuracy indeed. And in short, in summary, what is important to remember is that both approaches are great, but the big difference between a direct or indirect measurements is that with a phenomobile, you'll get probably the most robust results, but it's not the same cost as with a drone, right? So the cost on the phenomobile, or the cost if you're only using experts in the field, is much higher than what you would achieve with a drone, which is a lot more affordable and allow you to basically scale, right? In the end, this is really what we were seeking, is a solution that can be applied to a big portfolio of trials, not just one solution that would work on one specific trial somewhere in the south of France. It's not the case. It's got to be a solution that works everywhere, that is scalable, and that is affordable. So this is what we developed here with this UAV data pipeline here. And this is something that we then deliver through what we call Cloverfield, which is our data platform. So that's the platform we use to process automatically all of the UAV data. So UAV data goes in Cloverfield. It's automatically processed within a few days, hours and days, and the results are displayed on a web interface in which you can see your trial and you can inspect every single microplot. So here you can inspect each microplot, see each indicator traits for each microplot, and even see the raw image behind it. So you can actually see each microplot's images one by one to do even more validation. So this is a pretty powerful tool, and this is a tool that is processing millions of microplots each year so far across 12 countries worldwide. So it's an engine that day in and day out to crunch all of the numbers for breeders across the world. So with that, I guess I just wanted to insist on three things that we said last time that makes really Hiphen special. The first thing is we try to develop solutions that are bulletproof. And what we mean by that is that we really focus on developing a solution that can adapt to different field conditions. So we are not fans of solutions that we have to tweak every time we have a new situation or a new set of images coming in that on which the algorithm would not work. So we really focus on developing bulletproof solutions, and we try to be transparent. So I hope you've seen that in today's presentation. We are happy to share knowledge and to really ensure that you understand the method that was applied. And with our clients, we really insist on having them engaging with us on the methodology so that it's not a black box. Even if we use deep learning techniques, it shouldn't be a black box, and you should be able to have a level of control on the methodology to help us improve it as well along the way. And being agile for us means being able to allow you to scale, as I mentioned before. So three very important things. Now, with that in mind, I know what you're thinking, that how can I use all of that? Does that apply to my experiment? And we believe the answer is obviously yes. We do a lot of work for breeders, and we like tailoring a data pipeline to your needs. Depending on your crop, on your experiment, whether it's Cercospora or another disease, you would have to use a data pipeline that is tailored for your application and scalable to your territory. So this is really something that we'd love to talk about with you. To give you an example, we've been recently awarded a grant to tailor a solution to assess fusarium on wheat. So this is a program funded by the EU, so through the DIVA program, in partnership with Eurofins and Certis. And here, the idea is for Hiphen to basically look for the best sensor combination to deliver an affordable solution that would allow to assess the impact of fusarium on wheat. So this is back to what I was saying at the beginning of this presentation. The Hiphen is really a specialist in data fusion and looking for the right combination of sensors. So we have a sensor for every type of application, budget, and so on. But here we really do our best to bring the state of the art to the sector and to our clients. And obviously, that I wouldn't leave you without a message that says that our pricing is competitive based on data volumes, and would be very happy to discuss it in more details with you. What we tend to do is with our partners is to ask for a test data set. So if you've already done a UAV flight on one of your trials, we'd be very happy to process it for you for free and see what we can deliver. And that will allow us notably to tailor a proposal for you in that sense. So do get in touch if you're interested in that. And lastly, next Thursday we'll be talking about plant senescence modeling. So by all means, please join us for this webinar. So without further ado, we can then jump into the Q&A session. And I think my colleague Alexis is back with us. So Alexis, can you hear us? Okay, so while Alexis is connecting, I'd invite you to write your questions in the chat bar on the right if you want us to take any of your questions. Okay, please feel free to ask your questions in the chat. Okay, I'll take it. So the Amandine is asking us about Alexis is writing. So I see Alexis is trying to answer, but anyway, I'll give it a try. So Amandine is asking if the indirect measurement, given the measurement is based on F-cover, there is not a risk of confusion with other factors. So what we've, you will see all the details in the paper we mentioned, a lot of the work we've done in this controlled environment is really to make sure we fix the relationship between Cercospora infestation and the disease, and the F cover. So yes, indeed, there is a risk. Or Alexis is saying that as well. So there is a risk, and there's a reply to. I'll read Alexis' reply. So there are ways to mitigate this and make sure that the disease is the limiting factor for the biophysical variables we are following. So here you really have to bear in mind that this is a trial that has been under a lot of scrutiny, and the relationships and the correlations that we got, all of the details will be in the paper, but you can be reassured that even though there is a risk, the relationship we got with the ADPC, so the area under pressure curve, is really well linked to the Cercospora infestation indeed. Okay, is there any more questions? I see Patrice is writing a question. So yeah, Patrice is asking if we have experience on trees or perennial plants such as grape. The answer is yes. We have experience on grape. So we've done a lot of work over the last few years on grapes, not using drones, but we use a different type of systems. We've done a webinar a couple of months ago with MHCS, one of the biggest champagne producer in the world, for which we assess the impact of botrytis on their grapes. So we developed a system that takes close range images of their grapes and can attribute a quality score that assesses the severity of the botrytis on the grape. So this is something that we do mainly using deep learning techniques, very close to what we presented last week on plant counting, the level of techniques that allow us to take the expert knowledge, again through visual scoring, and apply it to this particular application, and so turning the expert knowledge into a quantitative indicator that is going to give a very objective quality score to the image, and each image is related to a particular crate of grape and so on. So it's a pretty powerful application and solution we developed here. On mildews on leaves, no, we haven't done much work on mildew. We had a lot of projects on salads, notably, for which we are starting to look into this type of problematic, but we haven't got any yet any specific results to show about mildew. No. But again, we believe that this is something we can look into, and we hopefully in the coming year also will be able to show you some examples and applications and results on this type of problematic on mildew. Thank you, Patrice. Any other questions from anyone? No? Okay. Well, if that's it, then I'll stop here because we always promise to keep these sessions very short. So I hope you enjoyed today's presentation, and so I give you rendezvous next week, next Thursday, to talk about plant senescence modeling. So if you want to register, you can go on our website, on our blog, or on social networks. Then we'll be happy to answer your questions next Thursday again. So thank you very much, everyone, for attending this session. And I say bye-bye, keep safe, and I hope we'll talk next week. Thank you very much, everyone.